Good day, grade 10 learners. Our lesson in this video is found in your Quarter 1 Math Module 1, 2, and 3. Please get your modules. Are you ready? After this video, you must be able to generate patterns. Number 2, illustrate arithmetic sequence. And number 3, find the nth term of the arithmetic sequence. Number 4, define and determine arithmetic means. Number 5, illustrate geometric sequence. Number 6, differentiate geometric sequence from arithmetic sequence. Number 7, find the sum of arithmetic sequence. And number 8, determine arithmetic means. There are terms to be remembered in this video. First, the term sequence. Sequence is a succession of numbers formed according to our rule. It is a function whose domain is the finite set or the infinite set. Example of finite set is the set of numbers 4, 7, 10, and so on, up to the last number n. Infinite set, in example of infinite set is the set of numbers 5, 9, 13, so on and so forth without end. That is why it is called infinite. Example, find the first 5 terms of the sequence with a general term of a sub n equals 2 times n plus 5. To get the first term, we will substitute our n with 1 from the word first. So that is 1. So 2 times 1, because n equals 1, n here is equal to 1. So substitute it here with 1. 2 times 1 is 2 plus 5. So 2 times 1 is 2 plus 5 equals 7. The first term is 7. For the second term, we will replace n with 2 here. So 2 times 2 equals 4 plus 5. The second term is 9. Or a sub 2 is 9. For the third term, we will replace our n here with 3. So 2 times 3 equals 6 plus 5. So the third term is 11. Will you please find the fourth term and the fifth term? You write it in your notebook. Another term to be remembered in this video is the term arithmetic sequence. Example, from our previous sequence, we have 7, the first term, 9, the second term, 11, the third term. If your fourth term is 13, then you're correct. And the last term, the fifth term is 15. Now, if you notice, 7 plus 2 equals 9. That is the next term to 7. If we add 9 plus 2, the answer is 11, the next term. So we have 7, the next term is 9, plus 2, the next term is 11. 11 plus 2 is the next term, 13. If we will add 13 plus 2, the next term is 15. So meaning we use 2 as the number to be added to get the next term. We call it the common difference. Again, the common difference is the number being added to get the next term. What is the common difference of the sequence 7, 9, 11, 13, and 15? Answer. If your answer is 2, then the common difference is 2. How to obtain the common difference of 7, 9, 11, 13, and 15? What's your answer? To obtain the common difference, we will just subtract the second term to the first term, and then the third term to the second term, and so on. So for example, 9 minus 7 equals 2, which is the common difference. We have 11 minus 9, still 2, the common difference. Or we have 13 minus 11 equals 2, which is the common difference. Or 15 minus 13 is 2, the common difference. Let us consider this situation. Find the missing terms of the arithmetic sequence. -1, blank, another blank, and then 31 and 39. So how are we going to solve this? First, we will find the common difference because it is stated that this sequence is an arithmetic sequence. All arithmetic sequence has common difference. We will use 39 minus 31. So the common difference is 8. To get the second term, this is the term after -1. -1 is our first term. So -1 plus the common difference 8 will give us 7. So the second term is 7. The third term will be 7 plus the common difference 8. The third term is 15. What do you think is the fourth term? So 15 plus 8 is 23, the fourth term. So the missing terms are 7, 15, 23. The missing terms are also called arithmetic means. When we say arithmetic means, these are the terms found in between the first and the last terms of a finite arithmetic sequence. In this arithmetic sequence, our arithmetic means are 7, 15, and 23. Another important concept that you must remember in this video is the formula on finding the nth term of the arithmetic sequence. The formula is a sub n equals a sub 1 plus the quantity of n minus 1 times d. Our d here is the common difference, and our a sub 1 represents the first term. It means the first number in a sequence. And n means the number of terms in a sequence. A sub n means the last term of the sequence. Example. Find the 20th term of the arithmetic sequence 2, 5, 8, and 11. So what is the 20th term? Solution. First, we will find the common difference because this is arithmetic sequence. Therefore, it has a common difference. So we can use 5 minus 2 to find the common difference. Or we can use 8 minus 5 to find the common difference. Or we can use 11 minus 8 to get the common difference. And then we will use the formula A sub n equals A sub 1 plus the quantity of n minus 1 times the common difference. Substitute 20 as our n. Again, n means the number of terms in the sequence. A sub 1 or the first term will be 2 plus n, again our n is 20 minus 1, copy 1, and d is the common difference, which is 3. So we have A sub 20 equals 2 plus 19. 20 minus 1, 20 minus 1 is 19 times 3, that is 57. 19 times 3 is 57, copy 2. So the 20th term is 59. There are instances that we need to add the terms of an arithmetic sequence. That is why you must always remember these two formula in finding the sum of arithmetic sequence. First, S sub n equals n divided by 2 times the quantity of 2 times the first term plus the quantity of n minus 1 times d, wherein d is the common difference. N is the number of terms, a sub 1 is the first term, and a sub n is the last term. Or you can also use the second formula, S sub n equals n divided by 2 times the quantity of the first term plus the last term. Let us try to answer this situation using the formula of getting the sum of an arithmetic sequence. Find the sum of the arithmetic sequence given below. The numbers between 1 and 81 which are divisible by 4. The possible sequence for this situation will be 4, because 4 is divisible by 4 and it is found in between 1 and 81. Next to 4 is 8, because 5 is not divisible by 4, 6 is not divisible by 4, 7 is not divisible by 4. 8 is divisible by 4. Then 12, because 11 is not divisible by 4. After 12 is 16, and then 20, so forth and so on, until 80. 81 is not divisible by 4. 80 is divisible by 4. And 80 is between 1 and 81. So meaning the last term is 80 and the first term is 4. Now since this is arithmetic sequence, we have a common difference, which is 4. 4 is coming from 8 minus 4, which is 4, or it can be 12 minus 8, which is also 4, or it can be 16 minus 12, which is 4, or from the given, which says numbers divisible by 4. Now, from our formula, we need to have n. To solve for n, we will use the formula of arithmetic sequence, which is a sub n equals the first term plus the quantity of n minus 1 times the common difference. Substitute, the last term is 80. The last term is 80. This one is 80. And then the first term is 4. Substitute it to the formula, so we have 80 equals 4 plus the quantity of n. We will solve for n. We do not know how many terms are there between 1 and 81, which are divisible by 4. And the common difference is 4. So simplify, we have 80 equals 4 plus, we have 4 times n is 4n minus 4 times negative 1 is negative 4. So we have now 80 equals 4 minus 4 is 0, so we have 4n. So n is 20 because if you will multiply 4 times 20, the answer is 80. Or you can have 80 divided by 4 and 4n divided by 4. n is 20. Since we have now the first term, which is 4, and the last term, which is 80, we also have the common difference 4, and the number of terms, which is 20. We are now ready to get the sum of the arithmetic sequence given 4, 8, 12, 16, so forth and so on, up to 80. These numbers are divisible by 4, and these numbers are between 1 and 81. We will use first the formula S sub n equals n divided by 2 times the quantity of 2 times the first term plus n minus 1 times d. Okay. So we will substitute n with 20. So n here equals 20. Our first term is 4. And our n again is 20. Our common difference is 4. Simplify. 20 divided by 2 is 10. 2 times 4 is 8. 2 minus 1 is 19 times 4. Simplify it further. We have 19 times 4 is 76. Copy 8 and copy 10. We have 76 plus 8 is 84. Copy 10. 84 times 10, that is the sum of the first 20 terms. Or you may also, we can also use the second formula. N divided by 2 times the quantity of a sub 1 plus a sub n. Again, our n is 20. Our first term is 4. And the last term is 80. 80 plus 4 is 84. We have it here. And 20 divided by 2 is 10. So again, 80 plus 4 is 84 times 10 is the sum of the 20 terms in between 1 and 81, which is divisible by 4, equivalent to 840. The type of sequence is the geometric sequence. We will use the paper folding activity to show how is geometric sequence is formed. First, we will find the area of this big square. We will let the area of this square equivalent to 64 square units. And then we will fold the corner to the center to make another square. So fold it to the center. You can also do it using any paper. You just make a square out of any paper. So fold each corner to the center. Fold each corner to the center. Okay. And we form two squares, smaller squares. The first square is this one, and the other is made up of 1, 2, 3, 4 triangles. And the two squares are equal. So what is the area of this square here? Coming from the area or the big square. Yes, the area of this smaller square is 32. 32 plus another 32 equals 64. Now, again, we will continue the process. We will, again, fold this corner here to the center to make it another square. Okay, so again, if you noticed, we form two squares, smaller squares. From the area, from a square with area 32, we form two squares, equal squares. So, this one. What do you think is the area of this square? Very good. 8. Okay. So we have now the sequence 64, 32, 16, 8. If we will continue, that would be 4, 2, 1, 1/2, 1/4, so forth and so on. Now we call this sequence geometric sequence. Now, geometric sequence is a sequence where each term after the first is obtained by multiplying the preceding term by a non-zero constant called the common ratio. The common ratio is the number being multiplied to get the next term. Example, in our sequence, we started with the area of 64 times 1/2, that is 64 times 1 divided by 2 is 32. 32 is the second term. And then, so 64 here is multiplied by 1/2 to get the next term, which is 32. And then 32 multiplied by 1/2. To simplify this, we need to multiply 32 times 1 and then divide by 2. The answer is 16, which is the next term. If we will continue the process, 8 here times 1/2 will give us the next term, which is 4. So we call 1/2 the common ratio. The common ratio is represented by R. So this is the common ratio, 1/2. We use 1/2 as a number we multiply to 64 to get the next term. We do not add here in geometric sequence to get the next term. Instead, we multiply. I think you're now ready to answer the application part and the assessment part of your Module 1, 2, and 3 for Quarter 1. This is to be recorded and graded as your performance tasks and written work respectively. Happy learning! Stay safe, stay healthy, pray always.